This week we'll finish chapter 3, well, which is one of the most important chapter in this class, and definitely is the most important chapter when you are doing your homework and when you will do your exam. Probably 2 weeks, 2 weeks later, next week. So we'll finish chapter 3 this week. So before we move on the content of chapter 3, let's have a quick review on what we have learned so far, because it's already like 5 days past before our last meeting, after our last meeting. So in this chapter, we have some knowledge we have discussed. What is the forecast accuracy? We introduced 3 different measurements. It's MAD, MSE, and MAPE. We have a short discussion on the difference between these 3 measurements. From my experience, MAPE is widely used in industry, especially for big companies with complex profile products. We also introduced a big category called time series forecast models. Basically, time series model is that the forecast based on historical data, nothing else. We'll discuss some other models as forecast depends on some other factors. But time series means, okay, we can just explore what's happened in the history to make our forecast in the future. That is the basic idea of time series model. But there's so many different models of time series. For example, Lai-Yu model, which is the simplest one we have discussed here. And moving average model, okay, it's very straightforward, but we have a short discussion that the real difficult part for moving average model is the choice of n. How to select n, that is really hard. And the weighted moving average model, have an example here, right? And the next one, exponential smoothing model. If you still remember, I write here there's 2 extreme cases of exponential smoothing model is that alpha equal to 0, which become ft equal to ft minus 1. That's you never change your forecast. Another extreme case is when alpha equal to 1, the exponential smoothing model become the Lai-Yu model, right? So between 0 and 1, that is the weight assignment difference for actual and the forecast. The exponential smoothing model. We have also the last one we just begin to discuss is called the linear trend model. Right? If we have the plots of historical data follow a linear trend, then we can build a linear regression model and use this model y equal to a plus bx to make the forecast of the future value. And that is what we have learned so far. Any question or comments? That's what we have learned until now. Question, Jack?
In exponential smoothing, I was looking at the homework and beta came up in it, like in a problem with exponential.
No, if you have seen beta is not exponential smoothing, it's the model we haven't covered. It's called trend adjusted exponential smoothing model. So that's what we'll cover this week. Any other questions?
And like it said something about, so are we going to determine how to use n, like how many n's to use this week for it as well?
Not in homework or exam, but in reality, definitely. If you say, I want to use moving average method to make our forecast, you have to determine the n. Nobody will tell you which is the best one to use. You have to use that. If you guys remember, that's the last class probably, I spent like 10 minutes to explain how to choose n. You can have different n, and you can compute the MAPE or MAD to see which n has the lowest forecast error or highest forecast accuracy. This is the n you should use. That's the general idea. Right? But we know that it's still hard if you have the infinite possible n or infinite possible method, then it's still hard. That's you should first say that's the 5 potential methods I will use, right? And then you compare these 5 potential methods, calculate the MAPE for all of them, and then decide which one is the best. Okay, that is what we did for industry. As for homework and exam, it's not so hard. It will tell you what's done. Any other questions or comments? Very good. No? Okay, so linear trend. Let's cover a quick review on linear trend. So linear trend, we first make our model. So ft equal to a plus bt. The first thing before we jump to any model, not just linear trend, before we jump to any model, we have to plot the data. This is very important. If your historical data is like this, I think it's too good to be true, but let's say it's like this. It obviously has a linear relationship between the time series t and whatever you want to forecast y. Right? Then you know, okay, you should be very confident to use linear trend model. On the other hand, if something, for example, small graph, like this curve, well, it still have positive relationship, but seems for us it's not a linear trend. Then you shouldn't use linear trend as your forecast model. Well, there's some other model, quadratic model we have introduced here, but you know that definitely linear trend is not feasible for that. Similarly, for any model we have discussed, like naive model or moving average model, you should have a very stable historical data, and moving average model can be a good fit for this data. So for anything you do, before you do anything while forecasting, first plot. That's not me teach you, that's my professor 10 years ago when I was taking the master level statistics course in Purdue University. It's a female professor from Canada. She mentioned that so many times. I still benefit from, I still remember what she mentioned. That course is based on linear regression by use SAS to do that statistics course. She said, plot. Whatever you show me, before you show me anything, I have to see your plot. When you do the homework, same thing. Well, before you jump, except for some homework told you, okay, use moving average model, that's fine. But if the homework say, or exam say, choose the best model you think is best, choose the model appropriate, before you tell me anything, show me the plots. Otherwise, I don't know why you choose this model. You can definitely explain something, except you are so smart or so strange, you just can look at the data, you already get the plots in your mind. I know some people can do that. But for most people, we should plot them. And then we have the region size, that's what we know, okay? Moving average is probably the best, linear trend, or some model we don't know. It's clear for you guys? Plot. It's Excel is like 1 minute. Even that you plot by your hand, probably only 5 minutes at most, right? So after we plot our data, then we should be confident, okay? So the first graph, okay, the linear trend model, most likely, is the best model. And write down this model. Well, A is the intercept and B is the slope, and T is the time series. And use the knowledge we have learned from business statistics course or the formula we have here to calculate that. Well, if you don't print out your slides or text your book, I definitely suggest you to copy this down because we will have an example in 1 minute. So, the slope, you have to first calculate this formula. The numerator is n, which is how many data points you have, historical data points you have. And the summation ty, so for example, if you t equal to 1, y equal to 10, you come together 1 multiplied by 10. And for the second period t equal to 2, if time is still equal to 10, y is still equal to 10, then 2 times 10 is equal to 20. You sum them together, that's the first term, minus summation t times summation y. That's the numerator. The denominator is n summation t squared, so you first get the square of each t and sum them together later. So that's this. What does this mean? And the minus first sum t together. Then for the final result of summation of t squared. Well, if I was still in the math school in Minnesota, I would never explain this. But since in business school, I want to everybody's clear about this formula because they are different. Some students ask me what's the difference between this one and that one. Well, it's different.
The difference is for the first one, t squared. You're gonna square all the t values, which are the periods.
That's right.
And then you're gonna sum them at the very end. And then for that, you're gonna take the sum of the t, and then you're gonna square that
That's
value.
right.
So,
That's right. Very good, Jonathan. So that's the difference. Clear for everyone? I think the numerator, most people have no problem, but denominator, a few students may have some confusion about these two different terms, right? And once you guess B, you guess the slope, then it's kind of easy. I would suggest you guys just use the second formula to calculate A. Well, you can definitely still use the first formula, but once you get the correct B, the second formula is very straightforward. Y bar, what does Y bar mean?
Y average.
Yeah, average of Y, right? Because Y is the historical value of whatever you want to focus, like demand, historical demand. And T bar is the average of T, which is the average of the historical period. And then, very straightforward, you will get. As everybody gets the formula? Everybody gets the formula? So, let's move on this example. So, a cell phone sales for California-based firm over the last 10 weeks are shown in the table below. First, I tell you, what's the data? Before, we're almost 100% sure we will use the linear trend model. That's why it's in this section. But still, we should first plot the data and visually check, see if a linear trend would be appropriate for these data sets. Then, if it is appropriate for these data sets, we want to determine the equation of the linear trend and make this equation of linear trend to make the prediction cell for weeks 11 and 12. So your data is only until week 10. So we want to make the forecast of 11 and 12. I will give you guys 10 minutes to try to finish this problems.
Video content.
Very careful when you do it. You have a calculator. With those calculators, I can do the problem. You can use your cell phone. Just remember to take your calculator.
Oh yeah.
In the future. we can discuss about the question. Great.
What time is your office hour?
Just after class until 12:30 sometimes. Okay.
Slopes.
What is your forecast for what is the
Time.
So equation is correct.
Plug in was
Well, first
I think you just need to plug in them, and then I don't need so much skills. Which one is plugging first step plugging date with the first. So if don't this formula and the final results, you should show what with the data packet. I don't need to like 10 steps.
Because I don't know.
I thought about 2 steps, and then the final results be like A, B, right? I don't know.
You add them all up and you divide them up. I remember the example.
what is T?
T
Like, is
is
it
the-
one?
yeah.
So you just use each one as you go through.
That's right.
Okay,
T
and then
is-
so then n is still 10, or do we do n as 12?
N is 10. N is the historical numbers, available number, because when you build up this equation, you only have these 10 numbers.
Okay, and then you just plug it in for 11.
Yeah, when you have the model, you have the equation later, then you plug in t equal to 11, 12 to make a forecast.
Yeah, and then you go each one, so it's like x on y basically, so like t becomes x.
Who?
And
Who didn't sign that?
is the y value.
Did you sign?
So, so like t becomes your x.
We should have.
And your y becomes your y. Unit cell, y is unit cell. So this should be like. It's like 1.7.
No, t and
It's like 7.
what do you ask? You ask n or t? N.
Whatever you can
Now is that is t the first is okay. We only have historical t until 10, right? T is 1 to 10. After you finish all stuff, you get your forecast model.
Because you take the sum of it.
Then you plug in t equals 11 and 12 to make a forecast. But when you calculate the slope and intercepts, t is only equal to 10 because that's all the data available for us. No, t here is summation, so t from 1 to 10. So you, each t,
So like this
you
is
take a square, so 1 square equal to 1, 2 square.
so you gotta go through all of these.
Together until 10
You
square.
gotta add all the t. So you gotta hit
Oh,
1
Professor,
720.
could you explain the same thing right quick?
Sure.
Plus 3 times the root plus the- you get the sum of that, and then you subtract.
Alright, so specifically, what did you say?
What I saying? I said a lot. So basically, So first, okay, let me explain to the class. Okay.
Okay.
All right, attention here. So several students have a similar question. Okay, still confused about the formula. So let's first figure out this number first. So for this question, what is the value of n? 10. Why n equal to 10?
It's the number. 10 times variance.
You have 10 historical data points,
Yeah.
right? So n is the number of historical data points available. You have 10 historical data. Sometimes why we can't use 11 or 12 because the question asks for 11 or 12, but this is for forecasting. This is you have nothing to do with your model. You use this model to make the forecast later, but when you build your model, the only available data is t from 1 to 10, which means n equal to 10. And then, what's the value of t here? What's the value of t?
Just
Each week.
yeah.
From 1 to 10, right? For example, if summation t squared, that means summation is 1 square plus 2 square
Yeah.
until
That's all with the 10 squared.
10 square,
Okay.
right? That's summation t square here. Summation t and that square is different, so it means 1 plus 2 plus 3 until
10.
and then take a square. So that's the difference, okay, between these two terms. I don't think you have any problem on this here, these two terms. Right? First, t times y, and sum together, there's a 10 numbers here, similar here, and then you should guess the results. I'll give you guys another 2 minutes, and hope you can at least get some value of slope or hopefully intercepts. We already have some students already finished.
In time.
That's gonna be a lot.
Yeah, but then we're gonna subtract.
Sum would be 41,000. And you times that by 10.
So it's 41, 350.
That is.
Times by 10, you're just gonna add a 0.
Does that look right? Sir?
So it's
Variable, but you still need to guess the final results.
13,000.
Oh, okay.
Yeah, B and A.
Gotcha.
B and A. And otherwise you can't make the forecast.
And then you subtract the sum of all the t's times the sum of all the y. So like 10 plus 9 plus 8 plus 9.
Okay.
It's 55 times whatever the sum of all.
Why is it in the silver? So it would be.
Times 55.
You said 7,000.
Okay. I believe some students already finished this question. So we have one student finish this problem like in 3 minutes. Yeah. So the students Herr Hermann from German, right? So could you tell us how to do this question? Yeah, everybody did by calculator, no problem. Yeah. Maybe you are really fast to press your calculator, but yeah. How do you plug in there? Here, tell me this number. N equal to what? When you calculate slope, N equal to 10. And then what is value of summation ty? Anybody guess this? Summation ty.
It's 41,358.
41,358. Right?
Right.
Anybody agree with what Jonathan gets?
Yeah.
Okay. Just be very carefully. Okay. So that means you have to calculate ty for this 10 value. So first one is easy. 1 times 700 is 700, right? The second 2 times 724 is 1448. Same thing. I would suggest if you are confused about that, you add another column. It's called ty, and then calculate each value or each pair of t and y. Okay, great. And summation t. Who can tell me what is summation t here? It is
55.
55. Great. And what is value of summation y?
7,407.
407. That's
So that's when you add up all.
you guys. This number everybody 7,407. Okay, great.
That's when you scatter them.
Very good. So divided by a10 summation t square. Who can tell me what is the value of summation t square?
385.
385. Great. Just be very careful. There's nothing hard here, but just we have to be very careful. And what is the value of summation t and square? Summation t is already we get 55, and then take the square. So what is the value?
3,025.
3,025. Like Aaron says.
Square root. So like,
It's correct?
you do the square root of 40.
Everybody gets the same result?
Where'd you get 3,025 from?
Well, you do 58.
It's
The
summation t
55 on the top.
You square
Hey,
it.
you
equal
just
to summation of t equal to 55, right? Take 55 square to get this number, right? Okay, so then I don't think anybody have any problem. Just tell me the last results of b equal to
Plus 4.
7.5.
9.
0.9, something like that, right?
Like that.
And then the next step, you calculate the slope, the intercept a, which is equal to y bar minus b x bar. It's minus or plus? There it is. Minus, that's right. Okay. So it's not x bar here. In fact, it's t bar. Generally, it's x bar. Here's t. And what is the value of y bar? Anyone volunteer here? Average of y. I believe somebody already guessed the results.
740.7.
730,
40.7.
47. Great. Okay. And you guess b equal to 509, and t bar equal to 5.5. You guys final results for the intercepts equal to
699.42.
great. Alright, so finally we get the model which is equal to y equal to you don't need to keep so many decimals, okay. As I recall in the homework exam you keep one decimal, that's enough. Right. So you can write this 7.5 t plus 6. Right, that's is your formula. Then what's the final step for this question? The answer. Predict sales for week 11, 12. How to do that?
Just plug it in.
Let's plug in. Yeah. So when t equal to 11, what is the result? What is the forecast?
781.9.
Let's round up, yeah. Kevin said it's 782 and the t equal to 12. What is the value? 700? 80, 89, somebody got it, 790 is fine. Because the reason I round this up or round it down is because it makes sense because it's the sales of cell phone. You should guess the integer number. Well, I have to warn you that usually you will miss 1 point. I'm a very strict teacher. So if in the exam, you give me a decimal number for the final results, you won't miss a lot, but probably 1 point. Because cell phone sales, well, makes sense. You can't sell 0.3 cell phone, right? You should have a reasonable round up or round down, that's fine. Right? You have your reason, but you should give me integer for the final results. So clear for this method? Yeah. Just be very carefully because many of you, most of you already have taken business statistics course. Well, maybe last semester, maybe 2 semesters ago. just be very carefully when you calculate the slope and intercepts, and then you should be fine. Question?
The 30-25, where'd you get that from?
55 squared.
Oh, okay.
So, it's clear for you, Sam? The summation t square, which is 55 squared, equal to that. Jack?
Is this the same as getting a linear regression model in the calculator?
That's right. That's we will introduce that. We'll explain that later in this chapter.
Oh, okay.
That 41,000, where'd you get that one at?
Which 1,000?
41,000.
41,000. So it's the t summation of ty. How do you guess that? So for the first one, for the first t and y is 1 times what 700? 700. Second is 2 times 724. You guess 1,448. Do the same thing for these 10 value, 10 pairs, and add them together. You will get 41358. Okay. Yeah. So if you are not so familiar, or sometimes you get confused about that, I would suggest what you I would suggest something to do that is that way. So you write down that first. The table you have like the t value and y here already, right? T value and y, and then you can add some other column like ty and t square, and I think that's pretty much. You add this these two new column and calculate for each one, and then sum them together. I will make you easy to follow the formula. But for many students, maybe you don't need to do that. But if you sometimes gets confusing, I would suggest you add these two columns, ty and t square. So you can calculate, okay, ty is equal to 700, and t square equal to 1, and ty equal to 1448, and t square equal to 4, and so on. This makes you easy. It's clear? Okay. Great. So, I finished linear trend model. Okay, now the last model for the time series category, which is not hard, but it can be very confusing. You will be very careful with this model when you are doing the homework. Because we have homework question on this model. It's called trend adjusted exponential smoothing model. Well, it is the extension of the traditional exponential smoothing model. Let's have a quick review on the exponential smoothing model we have learned here, which is here, right? Exponential smoothing model, the forecast is based on the previous forecast ft minus 1 plus the alpha, which is a smooth constant, times the difference or the forecast error at minus 1 minus ft minus 1, which is the exponential smoothing model. It's a basic one. Now, introduce the trend adjusted exponential smooth method. So this method, ST plus TT. ST, you can think about, is just a traditional exponential smooth method. The same thing. We'll see that. But we have a new term, TT, which is the trend estimate, which is new for the trend adjusted exponential smoothing model here. Okay, let me explain how to calculate that. So, now we have the symbol as the forecast is TAF, is trend adjusted forecast. Well, it's the same as forecast, but we just have TA before because it's a trend adjusted exponential smoothing forecast. And the forecast is equal to ST plus TT. Well, ST equal to TAFT plus alpha, which is a smoothing factor we have seen before in the exponential smoothing method. The forecast error here we have seen. It's actual minus the forecast of period T. You can see here, it's the same thing for ST versus what we have seen in the exponential smoothing. The only thing we change the symbol. Now here is FT, and now we use the symbol TAF T plus 1, but it's the same thing. So how do you calculate ST? Just use the same formula we have used for exponential smoothing model. The harder part or the tricky part is the T, the trend estimates. So the trend estimate is calculated in this way. Okay, if initially you have some trend estimates, right? For last period, TT minus 1, then you basically you trust your trend estimates. You think it's if it's a positive trend, that means you have the positive trend. If it's negative, you have the decreasing trend. You trust it, but you also want to adjust the results based on your performance of last period. So what's the performance last period? Is the last period forecast TFT minus the previous period forecast TFT minus 1 minus previous trend estimate TT minus 1. Well, I know the formula looks pretty hard to understand, and we don't have time to go through example in the class because this will take a lot of time. So that's the reason we have a problem in your homework. Okay, I use this method. I believe many students will have question and should have question when you do this question homework. Let me know. Then we can discuss. Okay, but there's nothing fancy here for the trend adjust forecast. It's just the expansion smoothing method ST plus the trend estimate. First question, Jonathan.
Yes. So TAFT. That's forecast.
That's
in the
forecast.
table. Okay. Alright.
In fact, if you don't like the way it's write for, you can just write FT.
Okay.
It's fine, but well, the reason they write TFT, they want you to know, okay, when they have TAF, you know it's trend
trend
adjust
adjusted.
forecast.
Okay.
It's not regular forecast, it's not a regular expansion smooth method. But if you find, okay, TF is confusing you,
Yeah.
you just write F.
Yeah, I thought that was something
Yeah.
we had to calculate. I was like,
No, this is
okay.
forecast. But you can see it's the iteration. You got the first step T and then TT minus 1, you got T plus 1. If you know some coding, that is the way it works. Jack?
That was mine as well.
Okay, same question. If you really don't like TF, you can write FT. I have no problem. I would suggest the last step you write, okay, TFT equal to 1. But for the middle step, you just write F.
Okay.
Make your life easy, right? Because it's still really the forecast. It doesn't matter. You can write whatever symbol you want. Just make sure you know it is a forecast. Okay, unfortunately we don't have time, but we have homework questions. Probably this usually from my previous experience, many students spend a lot of time on this question, and then first spend some time, definitely. But if you find it difficult, ask me. I will give you some hints, provide help. That's for sure. All right. Okay. Next techniques we'll discuss very important techniques for seasonality. I believe most people here will know what is seasonality mean, right? So seasonality is so common for so many different products and services we have seen in our daily life, and is expressed in the term of amounts that's actual value deviates from the average value of series. That we'll have a Halloween very soon. That we'll definitely see the candy's demand. It's much higher than the average candy demand, okay, except for this Halloween week. There are two basic models to handle the seasonality. The first one is additive model. It's very straight, right? You just add something, you think, okay, that's a seasonality. So our candy demand will increase by 100 units for our Food Lion store here. Then you just add 100 units. For whatever model you use, you can use a linear trend model for moving average model to make the forecast of the candy's demand. But you know that, okay, this model works perfect for usual weeks, but definitely not Halloween. Then you first get your forecast, basic forecast. Then you add 100 units to your forecast results. You say, that's my forecast for the candy's demand in the Halloween. So that's the additive model. That's basic idea. The second model is multiplicative model. Then you think, okay, if we just add some absolute value, it's not easy to handle this situation. We think it's a percentage. The percentage can be greater than 100% or less than 100%. It depends. Same example with candy. You think, okay, Halloween's candy's demand is like triple of our normal demand. Then you multiply by 300%. You just simply multiply by 3, right? And you have your basic forecast for the Halloween for the week, and then you times 3. That is your forecast for the Halloween's candy's demand. Let's see the graph. You can understand these two models. Well, you can see that from the curve, from demand curve, this product or service has very strong seasonality. Very strong seasonality. Like summer, very high, winter very low, and something like that. Can anybody give me some example of some products with this pattern? Ice cream, very good example, right?
Maybe wrapping paper.
Wrapping paper. Can be.
Okay.
And also like clothes. It depends which type of clothes.
Jackets and stuff.
Yeah, sure, definitely. Like swimming suits, well, definitely should have this pattern. So basically, it's summer high, winter low, and pretty normal for the spring and the fall. Right. But the second item also have this pattern. But you can see the difference here. What's the difference between the first item and the second item? They have similar seasonality. But what's the difference? Anybody can tell me the
Starts
difference?
out small and then.
The multiple one it varies more. Like
You mean the second one?
Yeah.
Yeah.
Yeah. So you can see the first one it have a seasonality, but the variation is stable, right? So year by year, okay, our ice cream fluctuation is pretty stable, right? So summer is 100 units higher, winter 100 units lower. That's year by year same. But second one, you can see the wave or the fluctuation is become larger and larger when our time series move forward. And then my question is that we know that we have two models to handle seasonality: additive model and the multiplicative model. For the first item or products, which model you think is appropriate? Additive or multiplicative?
For what?
First one. Which model you think is more appropriate? The two models here.
More appropriate for what?
For the first product, additive. That's correct. Before I ask why. First one, what about the second one? Which model should be more appropriate?
multiplicative.
Multiplicative. I want to first, maybe it's a challenging question, but can somebody explain me why for the second product, if we use additive model, what can be the problem? Is there any problem if Charles, I want to use additive model to handle the second product, is there any problem?
Be it the amount of time, the amount of time used.
Close? Jonathan?
You won't get an accurate
Yeah,
picture.
You
of
won't,
the
that's
forecast.
correct.
Yeah.
Not so accurate. Why is not so accurate if you use the additive model?
Well, the additive model, I mean, you know, was it you, Nima, who said?
Let's see the
He
last
said that the multiplicativeness has it varies more, so you have a lot more, and when you do the additive for the multiplicative, it won't live up to that
Variation.
window. Yeah.
Very close. Let me explain that. Very close.
Yeah.
So when additive model we have see here is add a constant number, right? It's add a constant number for the average, right? If you get average as added constant, how do you estimate the average? You estimate average by the historical data, right? Otherwise, how do you know the average? But historical data, you can see here, this not just seasonality, it has another pattern of this product. It's a trend. It's have increased trend, right? It has an increased trend. That means your average value increase every year. This can be your like Haagen-Dazs ice cream is very famous, okay, very popular, okay. Your demand increase, but you still have the seasonality. Well, if your demand is increased within seasonality, then it has a problem when you use additive model here, especially where it's larger and larger, because you calculate average based on the demand here, and you multiply, add the constant value, which the constant value, how do you get that? From previous data, right? Last year, you have 100 constants. This year, you have 150. Next year, the wave difference to 250. So when you add this 100 units, which you get, which is a fluctuation or variance between the summer and the spring, you underestimate, for this example, you underestimate the difference for the peak season, right? Then you will have problems. But if you multiply by something, it's fine. The reason is that because your average increase, you first get the forecast, average increase, then you get the increase average, then you multiply, say, 200%, you are more than 100 units different because the base is already larger than the last period. So that's why when you see an increase trend and or see the wave is larger and larger, you should consider the multiplicative model. Because the wave is the key. But here, because the wave is stable, we know that, okay, year by year, the difference is 100. It will keep stable, okay? Peak season versus regular season, 100 different, 100 different, 100 different. Yeah? The simple additive model will work. So that's why my professor told me, plot. You can see, plot is so important. Without plotting, you can simply find, okay, it has a seasonality. But which model to use? Which model to use? You have to plot them. Then look carefully. Because it's very easy to tell it has a seasonality, but it still takes some time to see that's larger and larger wave here until you plot carefully. Then you know which one to use. Any question or comments? Question? The key thing is that, okay, when the wave is larger and larger, the fluctuation is larger and larger or smaller and smaller, basically it's not stable, right? You should consider multiplicative model.
So when plotting, do we have to be like super accurate, or do we just have to get like a general?
Yeah,
like
definitely. When you use Excel, you definitely get super accurate.
Okay.
Yeah. When you do the homework, yeah, you can use your handwriting to do
Okay.
that. No need to be so accurate.
Okay.
But usually when you work in the industry, there's so many data. Use
Yeah.
Excel, then it's so accurate.
Yeah, I just meant with the handwriting. Not, yeah,
Yeah,
with
no
Excel.
problem.
Okay.
No problem.
Good.
Okay. The next topic we'll discuss is the seasonal relatives. Once we get the idea, okay, we plot the data, we find, okay, this product has very strong seasonality. We have to handle that. If we are not using the two models we have discussed before, we can use another model, which is the seasonal relatives. The seasonal relative is the percentage used in multiplicative seasonal adjusted forecast model. So we use this percentage, but we have to figure out what percentage we want to use. Right? Then we first need to deseasonalize the data. Right? Because it's very important. If we don't decentralize the data, deseasonalize the data, it's really hard to make any forecast. You think about if your data point is like this, well, we don't have any model we know how to handle this problem, right? We don't know. Moving average, definitely not. Linear trend, not. Economic smoothing, not very good. So we first have to deseasonalize data. We need to get a clear picture about what's really happened for the demand for these products. And then we can obtain the trend estimates and add the seasonality by multiplicating this seasonal trend. Okay, that's the general idea about seasonal relatives. So I'll give you a simple example here. So if you have some products, let's say 4 quarters, 1, 2, 3, 4, 100, 200, 110, and 50. Well, from this standpoint, it's really hard. There seems no pattern except we know seasonality. But if you know that is the seasonal relative, SI is 1, and here is like say 2, 1, 0.5. Then we divide by seasonal relative. We get the true or not the demand by removing the seasonality. We know, okay, 100 divided by 1 is another 100. 200 divided by 2 is 100. 110. And 15 divided by 0.5 is 100. Then you can see the demand become very stable. Then you can use the method you want to use, moving average, whatever, to use. Make the forecast for the next quarter, right? Next year, quarter 1, quarter 2. But after you get the next year's forecast, quarter 1, quarter 2, you need to multiply the seasonal relative to get a true forecast with the seasonality for this summer and the winter season. That's the basic idea how to use the seasonal relative. Again, we don't have time to go through example very detailed. We have a simple example here. So we have the question in your homework. If you have question, feel free to ask. Right? Okay, that's the end of today's class. We'll see you guys on Friday.